Hey folks, over on the desk today, we're going to talk about setting up a home lab. I'm not talking an IT style, network administration, computer science type lab. I'm talking more Raspberry Pi, Arduino experimentation, so STEM and IoT and stuff like that. Just a basic lab, but we're going to be combining aspects from both because there's a lot of crossover in this particular area. And where we're going to start today is with the server. If I can get my correct mouse in my hand, we're going to start on the server side of things. As always, we're using a Raspberry Pi for this particular project to kind of keep things in line with what you're going to learn in school. These are questions from Josh and Jeremy, so this is what we're going to focus on. I'm going to assume you already have a fully functional Raspberry Pi 4. I would recommend using a Raspberry Pi 4 with at least 4 gig for this function as the core server. And we're going to run just from that point. And some of the things we're going to do today is we're going to install Xrdp for remote desktop access. A lot of people prefer VNC. I do not. There's a lot of reasons for that. Some of it goes back years of just being jaded to the slowness, the security. If you're on the home network, it's probably not that big of a deal, but I actually prefer Xrdp because RDP, Remote Desktop Protocol, is installed on virtually every operating system out there, with the exception of Android and iPhone, but you can add it in there if you want. So yeah, we'll be installing Xrdp. We're going to configure Node-RED to run full time. And we're also going to install the Cockpit for monitoring. And that will become more obvious in the next episode when I've created a few more Raspberry Pis and set them up on the network so that you'll be able to actually come in and view status of each machine on the network, as well as be able to secure shell to each machine from within this single environment. And we'll talk about some other stuff as time goes on. A single SSH or secure shell session and sending the same command to multiple machines. This comes in really handy for updating. This goes back to cluster days, but we're not going to build a cluster. We just need to simplify our management. So that's a couple of the things we're going to work on today. So with that, let's go over here and take a look at our machine. Right now we have a fully running Raspberry Pi 4 gig. In fact, let me get the right mouse here. Let's add one thing to our build list, and that's sudo apt. First, we need to update and make sure everything's updated. Should be, this is a brand new, fresh, clean install, but okay, good. So we're going to sudo apt install neofetch. I love neofetch just for simplicity here. If I could spell this morning, I would be dangerous. Dangerous? All right, so while that's installing, I'm going to caffeinate. I'll show you neofetch here in just a second. In fact, let's get a slightly larger shell opened up. This lag, there's a latency here that's driving me nuts with my video capture. I'm running an HDMI video capture, so kind of like this one, right? The HDMI video plugs into that end. This plugs into a USB port and allows me to capture HDMI video. But it's slightly laggy and it's bugging me. Okay, so we have neofetch installed. Let me just show you what it does real quick. So it shows you the machine that we're running, right? You can already tell, we're running Raspbian. It's a Model 4B. Uptime, you can see which shell, you can see the resolution. I would actually like that, a wider resolution. That makes me wonder if it's downsampling that's slowing us down. so you can see exactly which version I'm running. Rename, let's take a look at what my name is. Raspberry Pi. I need to fix that. So let's run in and whoops, hit the wrong button. There's that lag kicking in. Let's run into RasPi config and just give this a good host name. KISS principle, right? Keep it stupid simple. Let's just call this one server. Well, I didn't want to close. Oh, good. It didn't close. Let's just check everything else. Yes, we want to log into desktop. We're going to disable splash screen. Personal choice. I like to see services starting as the system boots. If you just want a black screen up until you get to the desktop, then you would choose to enable the splash screen. Display, overscan already fixed. Interfaces, SSH is enabled. We're not going to do VNC. We're not going to do any of that for right now. Leave it standard, leave it standard. Okay. All right, let's do a quick reboot. While it's rebooting, we'll talk. Just looking over my notes here. So yeah, the gist of it today, again, is we've already installed it. We've added NeoFetch. Wasn't intended, but we did. We're going to install Xrdp next. And then we're going to configure Node-RED to run full time. And then we're going to do a quick walkthrough of just getting Cockpit installed. As I get a couple more machines running back here, we'll be able to talk about that a little bit more. So let's run up here. Sudo apt install Xrdp. RDP, remote desktop protocol. Essentially what it allows us to do down the road as well is to create several thin clients if needed. We can build, create, and provision thin clients. A thin client could be as simple as a Raspberry Pi 0W with a keyboard, mouse, and monitor attached. And we can run a full desktop off of that Raspberry Pi Zero by connecting to this with an RDP client. So this core server can expand way beyond just a simple box, but we'll talk about that down the road. So yeah, let's get this installing. While that is downloading and installing, maybe we should take a quick look over at Xrdp. Kind of kept these windows open. So it's a graphical login. Some of the older crowd are probably familiar with RDP. Some of the younger guys may be, guys and gals, may be familiar with RDP from school. I know a couple schools actually use remote desktop rather than physical access to the machine itself. But yeah, so that's it. It's really straightforward. We'll talk about that down the road and, showing you how it works. So that killed that little bit. All right, Node-RED is on this machine. I'm going to leave this terminal open. There is one thing we need to do, and I have the wrong mouse, to ensure that Node-RED starts up every time with the machine. And we need this command right here. Good God, that lag is killing me. Let's just paste that in this tab, right? So you can see that we're doing sudo, superuser do, system control. In other words, we're going to enable a service. Whoops, that says disable. I copied the wrong one. Enable. All right, so sudo, superuser do, system control. In other words, we want to add or remove a service, depending on the command. We want to enable the Node-RED service. Enter. Ta-da! Now Node-RED will reboot, or will start on every boot. So we can get out of there. Oh, close my terminal by accident. The next one is actually really straightforward. It's sudo apt install Cockpit. This only takes a few seconds, but I'm going to run you over and show you again our Cockpit, the Cockpit project, and some of the things we can do. You can get an idea of everything you can work with. It's a lot of remote administration brought into a simple web server. One of the things that I love about Cockpit is it doesn't require installing light HTTPD or a full-blown Apache web server. All of the services are built into the Cockpit application, so you don't need to do anything outside of just installing it. It works with basic libraries that are already on the RasPi. It's really a simple, appropriate system. You have multiple machines, so here you can see it gives us a shell built into the browser. I thought there was more. Okay, here's a multi-server setup, and we'll talk about this probably in the next episode as I get a few more machines. But you can see each individual machine. They are color-coded, and you can look here. In this case, we're looking at CPU or processor utilization. So we can see that Twin Peaks, Birch.Twin Peaks, here's our CPU spike, Pine, here's our CPU usage, and same thing with Palm. We know Palm's been pretty busy, but only over a short period of time. But yeah, it's pretty straightforward. So by now, we should have returned to our, yep, and we're done. Now, let's just go over and take a glance. I need my IP address. It's another problem I need to work on. I'm having an issue with name resolution. So I can actually show you that here. What we have, name resolution or domain name services, if you think about it, we're not very good at remembering numbers. Humans are not. So we know that this machine is named uname-a. This machine is named server, right? You saw me name the server and we reboot it. To us, that's a great name, but computers don't necessarily think that way. And we've talked about IP addresses. You need a physical address on your network, right? You can't say, well, you know, I'm going to call the police and send them to Billy Bob's house, right? The police don't know who Billy Bob is, but the police know who 10.0.0.195 is, right? That's the physical address of Billy Bob's house, or of server's house in this case. Probably not the greatest example, but I think you get the picture. But to make it friendly for humans, we assign them human-friendly names. So in this case, server. Because I may not always remember 10.0.0.195. So I'm having a problem on my network, and I can't quite figure out where it's coming from. The Linux clients are not resolving names 100%. It's hit or miss. And I know it's to do with my Comcast router. I just need to get some time to figure it out. Because I can actually, a majority of the time, look up the host name, but it returns the IPv6 address, which we did get this time. Yeah, we'll talk about that down the road. Far more advanced than just the scope of this. Let me switch over here, and we're at 195. Okay, so now we know we've installed Node-RED, we know we've installed Cockpit. Let's take a quick look and make sure that Cockpit and Node-RED are working as we need to. So we're going to go to the name or the IP address of our Raspberry Pi server, which in this case we said it's server. We just saw that it's 10.0.0.195. We're going to add colon 9090. In other words, we want to go to this host, but we want to connect to this TCP port, again, which is 9090. We're going to select our username on the machine and our password. We're going to log in. I'm just going to do a quick rundown to show you what is in Cockpit, and we'll add machines and talk about it more later in another episode. But so you can see here we're connected to server. we know the operating system, we know the status of system updates. Updates is important. I'm not going to overstress that. So yeah, just a quick glance. We can see our CPU, our memory utilization, disk input and output, as well as network traffic. We can access system logs. I've got a few errors I need to look at. They're probably nothing, but we can see the status of our disk storage, which in this case is one of these little micro SDs. Okay, I can show you. Let's see how that reacts. Let's go ahead and plug in a 128 gig USB, and let's just take a look. Does it instantly do it? Probably not. Ah, it did detect it. Hey, there we go. So it auto-detected the ad. So there's another plus for Cockpit. I have honestly not used Cockpit before, so this is going to be a learning experience for all of us. However, already I like it much better than Webmin, which was a previous monster. So yeah, so you can see we added our storage. We can click through. We can see our storage. We can see our file system types. Yeah. So let's go back to our overview. Take a quick look at our networking. Take a look at user accounts. Again, this is a Raspberry Pi. We only have 2 accounts to start with. Pi, which is the user you use all the time, and root, or the super user of the system. Never log in as root. It's a bad habit. It's a really bad habit. Always super user do anything that requires root access. There's very few things you will do that ever require you to log in as root. So log in as Pi, super user do everything else. Services. We can take a quick look at system services. Right? These are the types of services, any that are targeted. We can see what sockets are open and running. Same thing with system timers and global paths or system paths as we go through. Applications should be none. Software updates. We can see if there are any updates available, as well as what updates were done in the last update this morning, about an hour ago. Now we can open up a terminal session as well. Let me just double check, okay, and make sure that I'm recording the right screen. All right, we saw NeoFetch earlier. Oh, wrong keyboard, Rick. Let's run NeoFetch. There we go. We know that's working. HTOP, a colorized version of top, shows us a lot of the information we just saw in that web browser. At the top here, we can see our CPU's utilization, our memory, and our swap, what services are running, on and on and on. Pretty straightforward. So yeah, you can already see there's an advantage to this. I didn't have to go over and open up PuTTY to secure shell into the machine. It's integrated into this web browser environment. So I'm going to try and keep management as simple as possible. Kind of helps us all out, right? Okay, so we know that Cockpit is running. See, I'm trying to think ahead here and I forgot something. Anyway, so we know that Cockpit is now running fine. Let's go ahead and log out of that. Let's just run over and make sure that Node-RED, again, is our server name or address. Node-RED runs on port 1880. Okay, so we know if we do a refresh here, yep, we're going to reload just to make sure. Now, we know that Node-RED is now running on our server. What is Node-RED? It is a programmatic web interface. It is a top-down overview / programming environment. You can build dashboards with Node-RED. You can actually program things to happen on your Raspberry Pi with Node-RED. The boys are probably already familiar with it. The STEM students are probably already familiar with it. The rest of you, we're going to learn some stuff together on this in future episodes. I like Node-RED because I can make certain things happen easily. All right, anyway, so let's not go into that too much today and muddy the water. That's kind of it for today. Just a quick down and dirty start to our server and to kind of give you the idea of what we're doing. Coming up, some of the episodes coming up, the things, so we talked about configuring our server, getting the basics running. We're going to talk about doing the MQTT. We're going to go in as I get a few more Raspberry Pis running back here. We're going to talk about monitoring them. And again, we're going to do that through Cockpit. We're also going to talk about multiple ways to push out commands to these, we'll say these Raspberry Pis right here in my finger. Up here on the rail, you can see 3 of them. We're going to talk about how to take a single command from one machine and push it out to all of them at once. We're going to talk about building in storage. It may be as simple as, putting in a USB storage, USB thumb drive. We may add a couple USB hard drives to this, which is probably the option we'll go for. The reason for doing that is code backup, machine backup, so we can back up each Raspberry Pi to a common storage area. We could probably work on doing RAID where the disks are mirrored. So we'll have, let's just say, 2 1 terabyte hard drives. They both contain the same data. So if a hard drive fails, we still have a copy of that data. We'll talk about that. For another friend of mine, we're going to talk about a remote SDR or software-defined radio. We'll do the build on that, and we'll talk about integrating that into our environment so that we can access it from the Raspberry Pi server. We can access that from our desktop. If you're not familiar with software-defined radios, we're going to have a little bit of fun with that one. I think most of you know what a scanner is. It's a fairly common thing that people use to listen to weather or local police departments, the ones that still have public unencrypted radio signals. Yeah, it's a good way to listen to the radio spectrum around you. So we'll integrate that into our environment. And then we're going to start working on our lab environment a little bit more, of adding Arduino and some ESP projects. I don't know, temperature acquisition, humidity, things like that. Again, we'll incorporate a webcam that looks outside, bring that into our environment. Why not? Let's have a little bit of fun with it. If you've got questions and comments, post up down below. Don't forget, like the video, subscribe, and again, comment. So all the comments help me know what kind of stuff you guys are interested in. Maybe you see me do something and you know an easier way. Comment down below. Let's try and build this up a little bit. All right, guys, that's it for today. Be good, be well, wear a mask when you have to. Stay smart, stay strong, be mighty. We'll see you guys next time.